So we're just going to be solving problems involving the normal distribution. So you're going to have to take what you know and apply it to a unique situation. So 35,000 light bulbs, this is the value for n. This is the number of data elements in your list. Okay, so they've done some statistics. They see that it's normally distributed, and you get an average of 900 and a standard deviation of 50. So it says predict the percentage of light bulbs that will last between 825 and 875. Go for it. So on this picture, like, where do I put the 900? Right in the middle, right? And if you just do a few standard deviations, I'm just going to zoom in a bit. If you do a few standard deviations, what's one standard deviation to the left? That value would be 850. Very nice. One more standard deviation, you'd be at 800. Very nice. Now do that to the right side. To the right, you'd be at 950, and one more over, you'd be at 1,000. Good. Now you switch colors, and we're going to try to estimate 825 to 875. So if the entire space under the curve is 100%, about how much did I shade? About. Just by using common sense. Kyler says 25%. When I first looked at it, I guessed 30. Any other guesses? It's definitely less than 50 though, right? Why would it be less than 50, Harley? Yeah, it's in between the 50, right? About 20? Good, so you have an estimate. Now what we're going to do is we're going to find z-scores for those two values and then determine the area. That's how you do this. You use the z-scores that we learned about in the last lesson. So I'm going to answer like B, C, and D in this space provided. So let's find the z-score for 875. I just write the 875 in like a subscript. That just helps you stay organized. And you guys remember the formula. I'll put it up at the top. The z-score is equal to x minus the mean over the standard deviation. That's this formula here. So the particular data value that we're interested in is 875. And we subtract the average, which is 900, and we divide that by the standard deviation, which is 50. And remember, there's some invisible brackets there. You have to do that subtraction first. You have to do this with me so that you understand that the process. So that's the first z-score. Do the z-score for the other value, 825. We should expect that this z-score is more negative because it's farther to the left. So 825, subtracting 900, dividing by 50. I got negative 1.5. Okay, so let's give you about a minute to catch up, or 30 seconds to catch up. And then we're going to go and plot these z-scores on our curve. You guys got that written down? Okay, so this one's the negative 1.5. And this one's the negative 0.5. Remember, 0's right in the middle, right? 0's right in the middle. Does it make sense that the bigger value is farther away? Okay. Now we got to think back to how we calculate the z-scores. When we look at the chart, if you're away yesterday, I got the charts up here. Okay, if you want the chart paper, I'll just put it on my desk. Okay. That way you don't have to flip back and forth to the back of your book. So, if you recall, when you have a region that's smushed between two z-scores, do you guys remember the formula? Area big, take away area small. Do you guys remember that? So area big, take away area small. That's for when it's smushed between like that. The big area would come from which z-score? The one that has more area would be, well, the negative 1.5 is only this much. Okay, so area big comes from the z-score for negative 0.5, and you're going to take away the z-score for negative 1.5. So using your chart, find the areas for those z-scores, please. And then call them out when you get them. Yep, I agree. 0.3085. 0.0668. Subtracting those and you have the answer. It's 0.2417. So if you predict the percentage, a lot of us predicted between 20 and 30, and look what it ended up being. About 24%. Okay? Now, how many of the 35,000 light bulbs would you expect to have this range? That's where you have to take your percentage, this 24.17%, and then find the percentage of, which is a junior high skill. All you have to do is multiply the decimal by the number. This would be pretty straightforward at this point in your life. So 24.17% of 35,000 will be the decimal multiplied by the number. That's all it is. It's just the decimal of the percent multiplied by the number. So 0.2417 times the 35,000, and you get 8459.5 light bulbs. Can you have half a light bulb? So I would say probably 8460. I would round this one up. And at that point, you're pretty much splitting hairs. If this was like a numeric response and the question was 84, if you put 8459 and my answer was 8460, I would give you that. I'm not trying to like punish you guys. Okay? So 8460. So 8,460 bulbs will last between this many hours. Probably. Keep that in mind. Probably, maybe. Yeah. because a company can only predict what will happen. The future is not certain. Right? These are probability distributions. So this is a very heavy question, and this will be the written response in the test. Like, this will be the written response. You'll be given a unique situation you've never seen before. Maybe it's something else, not light bulbs. Maybe it's wax candles or something. And then you have to take what they give you, put it on the normal distribution chart, figure out some things, apply it to the situation. Okay, let's do the bottom question. Determine the probability that a bulb selected at random will last less than 920. So this is key. Like, you gotta highlight less. And obviously 920. What goes right in the middle, guys? I was gonna say dudes, but 900? 900 is the middle, right? Thank you. I just don't want to scroll up. So 920 is off to the right, and it's probably really close to it, right? Good. So that's 920. Yeah, 1 standard deviation. Good. So we're looking for the probability that you live in this space. So how many of your bulbs will last? Yeah, he predicted more than 50% of your bulbs will last less than 920. Do you agree with that statement? Yeah. That's a good way to just double check if you've done your math correctly. You know, does my common sense line up with my algebraic work? So z-score for 920, you'd go 920 minus the average, and then divide that by the standard deviation. So it's 20 over 50, whatever that decimal is. Thank you, sir. So go find the z-score for 0.4. .6554. So that is the probability. Probability. Probabilities can be expressed as decimals. Probabilities can be expressed as percents. So 65.54%, that's okay too. Probability. It doesn't matter if it's a decimal or a percent. Just be careful during your exam. Like, for the numeric response especially, it might say, like, to the nearest decimal, or it might say to the nearest percent. So just make sure you read it and do it appropriately. How do you guys feel about that? Let's get you some practice. Let's just jump to assignment question number 1. You're going to flip a couple pages up, go to assignment question number 1, and try this one.